Get through this assignment, and with any luck, make a good enough headway on the homework that you won't have a lot, because, I don't know, what should I have it? Stuff during spring break. So, here we go. Today, you aren't going to understand right now, this minute, you are not going to understand why we are doing what we're doing, because what we're doing here, does not really look at all like what we did yesterday, and it doesn't look like what we're going to do the next day, okay? But trust me, by the end of all this, it will fit together and you will understand why we're taking the time to do what we're doing. So, 9-2, the first part of it is what we call binomial expansion. Okay, what do I mean by binomial?
Two variables?
Well, two things, x plus y. It could also be x plus 2. It could be, z minus 5. Those are binomials, a two-part term. Now, right now, you could all do this problem. Everybody can do this problem right now. What would be your strategy? Start forming, you're distributing. So you would do x plus y times x plus y times x plus y times x plus y. Now you've all FOILed before, but this time you'd have to do it a whole bunch of times. Do you understand that? It can be done, it takes a while. Obviously, the bigger this number is, the worse it gets. Okay? So I don't want you to write anything down for a minute. I just want you to watch this. And I want you to start formulating observations. I know, because I'm old and I know the trick, I can do all this in my head. I want you to watch what I'm writing down and see if you can figure out what kind of pattern is emerging. Okay, if I do x plus y to the first, we know that's just x plus y. If I do x plus y to the second, that's a FOIL, and I get x squared plus 2xy plus y squared. If I cube it, that's a bigger FOIL, and I get x cubed plus 3x squared y plus 3xy squared plus y to the third. Please don't write this down. You don't need to know this. You need to see the pattern. So x plus y to the fourth, which is my question, is going to be x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Now, I wonder, since I told you what that was, I wonder if you could tell me what the next one would be. X plus y to the fifth. Any part of it, any observations you have. What? So you know it's going to start, I'm going to start it over here. You know it's going to start with x to the fifth and end with y to the fifth. Would everybody agree with that?
Yes.
Just based on what you've seen so far? Okay, what did you say, Eli?
Why?
Plus
7 or 8. I'll put 7 or 8.
X.
y.
No, it's not funny.
8x
Y.
to the
Oh, wait, no, it's y.
x y
This is kind of.
All right, let's you have made some great observations and you derailed a little bit. So let's talk about your great observations first. When you looked at this one, which I did for you, and this one, and this one, and that one, you notice that we started with x to whatever power this was, and we ended with y to whatever power that was. Everybody okay with that? Now, let's look at this one right here. Forget the numbers. Let's look at just the exponents for a minute. Okay, so this one was a 4 and that one was a 4. because that's a 4. Now, what about these two exponents? Remember, that's a y to the first. What about those? They add up to 4. What about these? And these. So in the 4th power expansion, all of the exponents add up to 4. Not only that, let's look at just the x's. X to the 4th, x cubed, x squared, x, and actually there's an x here, but it's to the 0 power. So what is happening to the powers on x? The farther we go in the expansion, they just start counting down by ones. Would everybody agree with that? Now what are the y's doing? Look at the y's. Aren't they doing exactly the same thing, but from the other end? Okay, so let's come back here for a second. I liked some of what I saw here. Forget the numbers. We know this is going to be x to the 4th. This is going to be x cubed. This is going to be x squared. This is going to be x. And that one is really x to the 0, right? And then y to the 5th is going to be y to the 4th, y to the 3rd, y to the 2nd, y. So there are my variables. Would everybody agree with that? And notice that each pair, the powers add up to 5, which is what they should in this problem. Okay? So we got the variables under control. Everybody's okay with the variables. Let's look at the numbers now. So I'm gonna rewrite this, except I'm not gonna have any letters in. I'm looking at just the numbers. So I've got a 1 and a 1. And then I have a 1, a 2, and a 1. And I'm writing it in this triangular fashion for a purpose, for a reason. Okay? So you probably should write this down. All I have done is write down the numbers from all this work that I did right here, which I know is right. This is right. And now I'm going to try to figure out what the numbers are that go in this one. You have already figured out that there's a 1 on this end, and there's a 1 on this end, right? You've already figured that out. You also kind of observed that the next number here is probably going to be a 5. See how it goes? 1, 2, 1, 3, 1, 4, 1, 5 probably. And if there's a 5 down here, won't there be a 5 down here also? See, isn't it symmetric? Now, it's these ones in the middle, so that's a 5, and this is a 5 right here. It's the ones in the middle that we have to really, really look at. It's so easy. This 6, for example, is the sum of 3 and 3. That 4 is the sum of 3 and 1. This 3 is the sum of 1 and 2. So if I want to build the bottom row, I've already got my 5. This is going to be a 10. This is going to be a 10. And that I already figured out was a 5. Now I know I'm down here really, really low, so you may need to stand up. Let's do one more row. What will the next row be? I know it's a 1 and a 1. Agreed? So then I'm going to have a 6, 15, 20, 15, and 6. So you know now how to build one of these all by yourself. Let me go ahead and put the numbers in. It was 1, 5, 10, plus 10, and then the 5 and the 1 I already had. That is what you get when you multiply this out 5 times. Wow, that's easy. That's easy. Let's try the next one. X plus 2y to the 3rd. Now think about our observations. Think about x plus 2y third. Where am I gonna get the numbers? Like here I had a 1, 5, 10, 10, 5, 1. Where did those numbers come from? They came from the 5th row of this triangular set of numbers. And why did I use the 5th row in this problem? Because it was the 5th power. So if I'm doing to the 3rd power, I will use this row of numbers. So I'm going to write down a 1, a 3, a 3, and a 1. Give yourself plenty of room. It's called expansion. Now, next to all of those numbers, you have, in this problem, x's and y's. Well, for us, it's a little different. We're gonna have x's, so I'm gonna put an x next to each of these. But I don't have a plain y, like I did over there. I have a 2y. Alright, so stop. Make a note if you need to. What's the first thing I did? If I'm expanding a binomial, the first thing I did was write down my row of numbers. Then next to each of the numbers, I put an x and a 2y. Okay? Now I'm going to put on my exponents. What did we decide about the exponents? Well, since I'm going to the 3rd power, the first exponent will be 3. And then what do they do? The x exponents count down. And then what do the y's do? Same thing but from this end. So 3, 2, 1, 0. Now, put a plus sign between each grouping and start simplifying, and you'll be done. What is anything to the 0 power? 1. So that's like gone. That's a 1. So all I have really for my first term is x cubed. Would you agree with that? Alright, now be careful here. You have a 3, but you also have a 2, and that's a multiply. This right here is a multiply, so that's going to be a 6 x squared y. Now what about this one? This is where we can make mistakes if we're not careful. See that 2y? It's being squared. So that's not really a 2. That's a 4. 4. So 4 times 3 is 12. This is all multiplied. So that's a 12 xy squared. And then what about the end? What do I have on the end? Well, you told me anything to the 0 is 1. So all I have is that right there, which is not 2y cubed, it is 8y cubed. Remember, this whole thing gets the exponent. There's your exponent. All right, let's try the next one. Okay, I need plenty of room here, so I'm going to erase. Everybody got what you need up here? Okay. So how do I start? What's the first thing I ought to do here?
Write down your row and
Write down the row. And what row, I'm going to leave my triangle right there. What row of my triangle should I write down? 5th row, right? So that's this one right here. So leave room in between. So 1, 5, 10, 10, 5, 1. All right, who remembers the second thing I do?
5th
fill in my X's and my letters. Now, be careful. This time, I don't have a plain X, I have a 2X. So every number gets a 2X, and please put it in parentheses. What else does every number get? A negative Y. That's a negative Y this time. So write down whatever numbers are in that row of the triangle. You do not have to memorize the triangle. You can build it. You know how to do that. We talked about it. Adding, building. Once you get the numbers written down, go ahead and put in your letters. And your letters are going to be this and this. Now what? There's really only one more step and then we'll be ready to simplify.
The exponent.
Do my exponents. And I know that on the first term, which is 2x, the first exponent is going to be 5. And then they're going to count down. If you're leaving yourself plenty of room and you're organized, it's easy. Just count down. Then do the same thing on the ones. Other direction. You can kind of check as you go, because what did we observe about each term? The exponents in each term have to add up to that, right? So if you get off, you'll notice that they have to add up to 5 in this case. All right, put nice little plus signs in there. Those separate each term. And remember that this whole shebang is times. So who can tell me what the first term is when I simplify it? It isn't 2x to the 5th, it's not 10x to the 5th. 32x to the 5th. Why is it 32x to the 5th?
Oh, because it's
2 to the 5th. You'll have a calculator to help you with this. All right, now let's look at the next term. Remember, this is all multiply. So what am I multiplying? A 5 times a what? What's this?
2 to the 4th.
Which is
It is 16.
16 times a negative 1. So I'm multiplying 5, 16, negative 1. This is a multiply problem. We're multiplying, not subtracting. So what's 5 times 16 times negative 1? Negative 80. And then I got my x to the 4th and my y. All right, what about the next one? What am I multiplying? I'm multiplying a 10, an 8, and be careful, what's negative 1 squared? 1. So with that one, it's going to be positive 80, isn't it? X cubed y squared. All right, what about this one? What am I multiplying? I'm multiplying a 10, a 4, negative 1. Remember, a negative to an odd power is negative. So that's negative 40 x squared y cubed. What am I multiplying here? 5, 2, 1. So that's 10 xy to the 4th. And finally, what do I got down here? Anything to the 0 is 1. So all I have is negative y to the 5th. right, now, the next one says, find the fifth term of 2x plus y to the 11th. Now, I want you to think about that for a second. 2x plus y to the 11th. Would that be pretty big? I mean, would that be pretty long this way? Yeah. Luckily, we don't need to do the whole thing. Luckily, we only have to find the fifth number in the list. Like here's the whole thing for the problem we just did. This right here would be like the third term. Well, we want to find the fifth term of this. Now, the fifth term, just like up here, the fifth term is going to have a coefficient or a number. It's going to have a number. It's going to have a 2x to some power, and it's going to have a y to some power. Would you agree with that? Every term has that, right? Now, does this bother anybody?
Can you put a 5 and a 6?
Well, I don't know what they are. I can count. You mean here in terms of exponents? Absolutely, I can count it out. I'll use my fingers. On the first term of this expansion, it would be x to the 11th. And then 10th, 9th, 8th, 7th. That's the one I want. So it's actually going to be 7. 11, 10, 9, 8, 7. Does that make sense to you?
Yeah.
And, Samaya, the minute I know that one's a 7,
And the other one's 4.
the other one's got to be 4. So I got that part figured out. I just counted. I just counted. Now, what I'm still a little squeamish about here is that this coefficient comes from where? Where did this 10 come from? That? Does that bother you? What row of the triangle would I look at? The 11th row. Okay, so I got the 6th. So I have to, it's already pretty big. I'd have to make the 7th, 8th, 9th, 10th, 11th. You can do that. Absolutely, you can do that. But there's a shortcut. And here's where it starts to tie into yesterday. Take your calculator out for me. All right, so Jacob and Jeanette, I want you guys doing what we learned how to do yesterday. I want you guys to type in 5C5, just like we did yesterday. I want you to do 5C4. Allie, I want your row. Everybody behind you, you're doing 5C3. Plumber, behind you, you're doing 5C2. Eli, you're doing 5C1. And Quinn, you're doing 5C0. I just want you to calculate those numbers on your calculator. So remember how we did that? Press 5, math, prob, NCR 5 for this one. 5, math, prob, NCR 4. 5, math, prob, NCR 3, and so on. Anybody got a number? What you got, Jacob?
1 for.
Jacob's got 1 right here. Jacob got a 1. Anybody else got 1? 5C1 was 5. Why did you do 5C1? You were supposed to do 5C3. Okay. Anybody got another one?
5C2 is 10.
This is 10.
5C4 was 5.
5C4 was 5.
5C3 is 10.
All right, I want you to notice something. Have you seen that set of numbers before? That set of numbers is the 5th row of the triangle. So the combination, the C numbers, are the rows of the triangle. So if I wanted the 11th row of the triangle, my first number would be 11C11. What would my second number be? And then 11C9, 11C8, and 11C7. Isn't that the 1, 2, 3, 4, 5th number? And that's the one I want. So we go to our calculator, 11C7, it'll be kind of big. What'd you get? 330. Now, how did I know it was 11C7? I counted. Nothing magical. I counted. Got down to the 5th one. Typed into my calculator, got 330. I already had figured this part out, so now I'm ready to write my answer. What am I multiplying? 330 times 2 to the 7th, which is 128, double check that. Is that 128? And 1. That's what I'm multiplying. So what's 330 times 128? 42,240. X to the 7th, y to the 4th. There is the 5th term of that expansion. If you FOILed this all the way out and counted down, the 5th term in that big long string would be that guy right there. This triangle, before I erase it, this triangle is called Pascal's triangle. Have you ever heard the word Pascal before? It's a name. This guy's name, Blaise Pascal. What?
There's a basketball player.
Yeah, the gecko.
That's great. I wonder what his parents, is that his first name or last name? First name's Pascal? Wonder if he's got mathematicians for parents, because Blaise Pascal is one of the great mathematicians. Yeah. We'll talk a little bit more about him. There's some interesting stories about him. But we don't have time to tell them. Maybe I will have time at the end of the period, but we got a few more problems to do. So, let's see if we can do what we just did for this problem. X minus y to the 10th. Would you agree that if I were to write this all out, the first term would have an x to the 10th, and the second term would have an x to the 9th, x to the 8th. Would you agree with me? Okay. So I am interested in this term right here, because I want it to have an x to the 4th, and then it obviously will have a y to the 6th. Would you agree with that? So there's a term somewhere in this list that has a coefficient, a number, one of these. It has an x to the 4th and a negative y to the 6th. Now I gotta figure out what this coefficient is, so I want you to think about what we just did. Which row of the triangle would we be interested in? If we were gonna write all that out, which row would we go to? The 10. The first number, this would be 10C10, 10C9, 10C8. Well, wait a second. Isn't this one just gonna end up being 10C4? I mean, can you kind of see that just from what I got going here? All right, what's 10C4? What's that number? 210. X to the 4th. Does that negative stay or go? It's to the 6th. Is it gonna stay or go? It's gonna go. If you take a negative to an even power, kids, it goes away, right? Come on. You know that. So what was the question? What is the coefficient of that term? The coefficient is 210. What's the matter? Why are you looking that way?
I thought it would be the seventh. I thought it would be 10C7 instead, because like I just said counting yesterday, I guess. Wow.
Okay, this says that we have to have x to the fourth.
Yeah.
Okay, so we have 10, 9, 8, 7, 6, 5, 4. So this is 10C10, 9, 8, 10C7, 10C6, it's 10C4.
I was counting up. So,
Okay, even then, it wouldn't be 10C4, it would be 10C6. So double check your counting from the other direction. Okay, last one, and then we're gonna do some calculation here. Last one, 2x plus 3y to the fifth, and we want the third term. So 2x plus y to the fifth, and we want the third term. Now, this is just like problem solving. So you know that the first term would have a 2x to the fifth, right? The second term would have a 2x to the fourth. And the third term, the one you want, is going to have a 2x to the third, which automatically means you're gonna have a y to the,
Miss Ford, I think it's supposed to be 3Y.
oh, is it 3y?
Yes.
Okay, well, that changes this right here. Thank you for catching that right at the right moment. Thank you. So my 2x's to the third, and then just count it down. And that means my 3y has to be to the second, because these gotta add up to 5. Okay, everybody got that? Now I need my coefficient. I need to know what number is gonna go out here in front of that.
5C3.
I know that the coefficient here is 5C5. Here, it's 5C4. What's it gonna be here? 5C3. Now, we already had our triangle written out, so if you wanna use this, it's fine. The third coefficient's 10. If you type 5C3 on your calculator, you'll get 10. So you can always use the triangle. It gets awkward if the number's too big, but you can always use the triangle. So there's your third term. So what are we multiplying? We're multiplying a 10 times 8 times, watch it, what's this? 9. So that is 720 x to the third y squared. You okay with that? All right, evaluate by hand. New notation, all you gotta know is that this is the same as this. They mean exactly the same thing. So when you see two numbers written on top of each other like that with parentheses around them, that's a combination, that's a C number. First, second, so 7 things chosen 3 at a time. Now, you can type that in on your calculator, but this says evaluate it by hand. There is a formula for this, it's very easy. The formula for combinations is first number factorial over the subtraction of these two and the second one, okay? So the first number factorial goes on top, then subtract these two numbers, so I'm gonna get 4 factorial, and then that number 3 factorial. So if you wanna write down a formula, the actual formula looks like this. N factorial over n minus r factorial, r factorial. Basically, it's the first number over two things. And the two things are the subtraction and the second. Now, evaluate by hand. What does 7 factorial mean? Talk about this
7 times
yesterday.
6 times 5 times 4
So
times 6.
that's gonna be 7, 6, 5, 4, 3, 2, 1. So 4 factorial is 4, 3, 2, 1. And 3 factorial is 3, 2, 1. Now you see what's gonna happen?
Cancels.
A whole bunch of stuff is gonna cancel every time. All of that's gone. 3 times 2 times 1 is 6. So what's the answer to the question? What's left? 7 times 5, so it's 35. The answer's 35. Never, if you're doing it by hand, please never multiply all this stuff together. Just write it out and start canceling. It'll always cancel a whole bunch. Okay, HC3. By hand, what is HC3 going to look like? 8C3 will be 8 factorial over 5 factorial, 3 factorial. Where do the bottom numbers come from? Subtract and the last number, right? Two things down there, subtract and the last number. So what's 8 factorial? You know what that is. And then over 5, 4, 3, 2, 1. So all that's gone. That's gone. What's the answer to that one?
35.
No.
Oh, I'm looking at the bottom one. My bad.
56.
56.
All right, now remember that vertical notation means combination. So letter C is 100C98. It's just a different way of writing 100C98. So what's that gonna be? 100 factorial, oh Lord, divided by 2 factorial, 98 factorial. So divided by 2. So before you get too panicky, stop and think about this for a minute. 100 factorial is this. Would you agree with me? And 98 factorial is this. Isn't all that going to disappear? So you don't need to write it all out. Everything from the 98 on is going to be gone. But you do still have a 2 times 1 down there. So you're gonna have basically 50 times 99 is what's left, because 2 will go into 150 times. So what is that? I'm gonna cheat, use my calculator. 99 times 50, 4950. Everybody okay? All right, try the next one. Try 11C6. That's what it really is. It's written differently, but it's 11C6. See if you can evaluate that. After you get all your canceling, you can use your calculator. As your lazy teacher is. I got 462. I don't know if that's right or not. Everything from the 6 on canceled with this, right? Then I had 5 and 2, I canceled out my 10. 4 goes into 8 twice, 3 goes into 9 3 times. So I was left with 11, 3, 2, and 7, which I times together and got that. Everybody kind of following along a little bit? Okay, one more, 10C7. Then we're gonna talk about P's. 10C7. That was a little easier, I think, if I did it right. I got 120.
Yeah.
Alright, now this next one's a P from yesterday. Who knows the difference between C's and P's?
He is like the sign rolls, he is like anything.
Order matters.
P order matters. So what this problem means is there are 10 options. I'm picking 2 of them and order matters. This means there are 11 options. I'm picking 6 of them and order doesn't matter. Okay? The formula, obviously they made it for things, so the formula is a little bit different. NPR is n factorial over n minus r factorial. So NPR, the P problems, have only one thing in the denominator. They have the same thing on top. This number goes on top. But the only thing in the bottom is the subtraction. Factorial. That's just gonna be 10 times 9, isn't it, or 90? Because everything from the 8 on is gonna cancel with the denominator. Does that make sense to everybody? So the C's and the P's look exactly the same, except the C's have this number in the denominator too. All right, do 8P5 for me. What's 8P5? Oh, it's gonna be a big number. $67.20, is what you got? All right, go ahead and get out your, yeah. 924. Well, you're getting that out. If you toss a coin, one coin, you're either gonna get a head or a tail. Would everybody agree with that? Yeah. If you toss that coin twice, you can get 2 heads, you can get 2 tails, or you can get a head and a tail or a tail and a head. So there's one option, one option, one option, 2 options, one option. Oh. If we toss that coin 3 times, we can get all heads, we can get all tails. We can get 2 heads and a tail, or we can get 2 tails and a head. One option, 3 options, 3 options, 1 option. You ever see those numbers before?
Yeah.
It's called Pascal's triangle because Blaise Pascal was very, very smart. He ran around with a not so desirable group of people. They were called gamers. Back in that day, we would think of them as gamblers. But they knew he was smart. They said, Blazo, buddy, come up with a way that we can win the game. This is the beginning of game theory. This is the beginning of the study of probability. And it all started with Pascal's triangle, and it started from coin tosses. We will do some probability problems like this when we get a little bit further in the chapter. But that's where it came from. That's where it all started. Okay, we're on our homework though. That's what we're doing now. He died at a pretty young age.
How'd he die?
I'm not sure. It could have been drug overdose. I'm not positive. Most of the great mathematicians were just weirdos, and
Pascal was partying. Sounds like Pascal was having a good time.
Descartes was part of the court. He was a noble person. But like Pythagoras, you know, we have the Pythagorean theorem, and we all think, oh, he's so wonderful. He was ostracized from Greek society. He had a cult. He lived out
Yeah.
of the society. Yeah, I mean, these guys, and part of it was, they were so smart that they couldn't really, like, relate to, like, normal people.
They have like autism or something?
I don't know, I wasn't around back then. I've been here a long time, and I wasn't around back then. All right, x plus 2y to the fourth, we're gonna expand it, circling our answer. All right, so here we go. How do we start? This is the very first thing we did today. So first I start by writing down my numbers. Now, that is a pretty small number, so I usually keep my triangle, oops, not like that. Keep my triangle handy. You have it written down in your notes. And if it's only to the fourth power, it's faster to just write that out than it is to figure all the C numbers. But this is 4C4, 4C3, 4C2, 4C1, 4C0. So I'm gonna write down those numbers. 1, 4, 6, 4, 1. Now what, anybody remember?
You put in your variables.
I put in my variables. So in this case, Samaya, we're gonna have an X. Everything gets an X. And we're gonna have a 2y. Everything gets a 2y. Now what?
Your exponents.
Exponents. I know that on my first x, my first power will be a 4, and they are going to count down. My y's will do exactly the same thing from the opposite end. Don't forget to put big old plus signs in between each term, because you have to recognize that this part gets all times together, and then this part gets all times together, and so on. So what happens here in term 1? Just x to the 4th. You can put the 1 in front if you want, doesn't matter, don't need it, but you can. Remember, anything to the 0 is 1. This whole thing is to the 0, so that's 1. All right, what am I multiplying here? 4 and 2, so 8 x cubed y. Now here's where we start running into problems. Be careful. What am I multiplying here? 6 and 4. 4. Right? Everybody see 4? So 6 times 4 is going to be 24 x squared y squared. Same thing here. What am I multiplying? 4 and 8. So that's going to be 32 xy cubed. And then what's on the end?
Uh,
16 y to the whole thing is your answer. Just draw a big circle around that thing and you're done. Alright, let's do the next one. 3x minus 2y to the third. Okay, so let's do the exact same thing. So what did we do first? We wrote down our numbers, and the numbers I can get right here, third row of the triangle. So 1, 3, 3, 1. Next to each of those is gonna go what in this problem? A 3x and a negative 2y. Now these are being multiplied, not subtracted. 3x, negative 2y. Everything gets a 3x, everything gets a negative 2y. Then what? Exponents. And this time on our x, we'll start with a 3. So 3, 2, 1, 0, okay? And then 3, 2, 1, 0. They have to be in that order, guys, okay? So make sure you're going, starting with 3 and going down on the x's. Okay, put big old plus signs in between and we are ready to simplify. Do not screw this up. Anything to the 0 is 1. So this is like not even there. So what do we have? 3 to the third, which is 27 x cubed. Now there's a lot going on here. I have a 3, I have a 9, and I have a negative 2. Those are being multiplied. So what's 3 times 9 times negative 2? Negative 54. X squared y. Three times 3 times positive 4. Is that right? Which is what? Positive 36. XY squared. And then again on the last term, this is not there. Ignore it. It's not there. It's to the 0 power. Negative 8y to the third. Put a circle around that, and that is the answer to that one. Okay, maybe we can get this number 2 done, I don't know. Find the fourth term. Now, I went ahead and wrote my triangle out to the 6th row. Why did I take it to the 6th row? Because it's to the 6th power. I want the fourth term. 1, 2, 3, 4. 20. What are the two things in the problem? A 2x and a negative y. What about the powers, guys? Here it would be 6. 5, 4, 3 on the x, 3. And if that one's a 3, then so is that one. So all you're left to do is simplify this the way we were simplifying each of those. And that will be the answer to that one. Okay? That homework's due Thursday, but you're almost done with it. I would expect that to be turned in real soon. Like now.
That one, 64.
Six, six, 5, 4, 3. You gotta count down. This is 66.
Thank you, Miss Ford.
5, 4, 3. 63. Bye, I'll see you Thursday.